So let us move on to the feature of the island. As you can see from the appearance, it is definitely a convective system, and from the scale, probably a mesoscale one. If you look at the image, it was in SATREP defined yesterday as mesoscale convective system, so definitely a nice one developing over Ireland. And Johan has provided us with some very nice images. This is the one from showing the system close up in the air mass RGB. If you look at the colors, then you will see that you have here some reddish color, pointing out that you have a very strong protrusion of the dry stratospheric air down there. You saw it also when we looked at the isentropic potential vorticity values, that here you had the highest values, or the deepest location of the one IPV unit. Also, what is very much prominent is the low in 500 hectopascal, so you have a upper level feature here. And this mesoscale convective system is actually developing due to a strong vorticity advection also in this region. This was also something that we saw before. This is the IPV, so potential vorticity and you can see that the value 1 reaches down to almost to the ground, so very strong upper level process, which is then responsible for the development. In this loop, which will come if you are patient, you can see the development very nicely. So the curling up of the occlusion due to vorticity advection, and the development of the mesoscale convective system over Ireland, with definitely some serious showers there. So I hope you all saw the loop. Do you see the loop? It came quite quickly in my screen, but I'm not sure. Okay, okay, fine. No, some of you don't. Okay, we can wait a little bit. I'm sorry. I know about this problem, because when your internet lines are slow, then these loops appear after a few minutes, which is not very nice, but I can't help it. So now we move on back to our bigger view, and what we would like to see is is the situation over Northeast Europe. So if you look at the situation yesterday at 6 UTC, you will see that the low or the occlusion over Eastern Europe is still not developed completely. At 0 UTC today, you could already see you can already see the spiral very nicely, so the occlusion develops. What is also very striking in this image is a red line wrapping around this occlusion cloud band, showing the intrusion of the air from high up from stratosphere, because it is very much red, which means that in the water vapor image it is very dry. Also over the Atlantic, very nicely, some development in the cold air behind the front that we saw. What I wanted to show you was the cross-section crossing the occlusion cloud spiral, the one here, which actually in its ending part crosses the cloud spiral. And why I wanted you to see that, it's because it's a typical occlusion cross-section. So actually more or less when you see this V or epsilon feature in your cross section, then you can be more or less sure that you have an occlusion in this case. It's so a very nice cross section of the occlusion. A temperature advection also shows quite a typical setup for the occlusion. So you have a pool of cold air inside and warm advection from a side. So you have a pair of cold and warm advection in the vertical, the same as you have it in when you look at the occlusion in the horizontal. So when you look at the occlusion spiral and you put on the temperature advection field, you will see that you have this pair of cold and warm advection always present. So this is a typical feature. Another thing that you have here very nicely pronounced, and this is something that gives you the idea that this cyclogenesis is quite a strong one, is the potential vorticity, which not only has the maximum in the upper levels but also in the lower layers, and these two maxima are actually connected, showing you that this cyclone is already developed one. Usually when you have the let's say the beginning of the cyclogenesis, then you would have a maximum like this here, but this is nothing to do with it, but you would have a maximum like this in the upper levels and the small one somewhere here in the lower layers, and then when they somehow join, you have a cyclogenesis in place, so you already have a developed low. So this is why I'm showing this. Is the reason is that this is quite a typical cross section of the cyclone. And now we have today's situation. So today we could also go back a little bit to this air mass loop, which shows you how this. Sorry, I will just put this marking up, which shows how this low is developing and how the dry air or the coming with the jet here is wrapping around this cloud band. It doesn't show the situation from today but from yesterday, but you can still see the development quite nicely. I hope you can see it. So to go on, as you can see, today's situation is quite clear from the point of view of this system over Northeast Europe. You have already quite nicely developed low here. The upper level feature, or the upper level chart, the 300 hectopascal field shows you that you already have quite a deep low up to the upper troposphere, and also here over the Atlantic the same thing. So you have a low up to 300 hectopascal, probably even higher. Still over the Atlantic some development in the cold air in the center of this low. Still going on, so convective clouds developing. Some convective clouds also developing over the Adriatic again in the morning. Again, the situation was quite similar to the one from yesterday. There was quite some instability indicated by the nowcasting SAF and MPEF instability products. However, their instability was a bit lower than yesterday, so it was not so unstable, and the development is also not that prominent. There was only one large cloud system developing over the Adriatic, but it is, as I'm speaking, it is now beginning to decay. This is so the situation from today. If you look at the model data, so if you compare if you compare the infrared image with the model image, then you will see that the model has forecast the cloud bands quite well. So in the right place, almost no shift if you look at the main cloud systems. Also, the system over the Adriatic, which is convective one, was more or less well forecast. So there was clouds forecasted in the model. So you can be quite sure that your model is correct for today. So if you're about to forecast the weather for today, you can go on with the ECMWF forecast. It seems to be quite correct for today. In the end, the weather connected to the features that we saw today, so quite some rain in the northeast, all along this occlusion cloud band. Some rain also here in the west, with this system coming from the Atlantic, also in Ireland, as far as I can see. There was some rain also here in the Adriatic, but only at the open sea, more or less. And the rest of Europe seems to have quite nice summer weather with clear skies or only slightly cloudy. And it seems to be keeping like that in the next, let's say, 10 days at least. In the south of Europe there will be sunny. So those of you who still have chance to come to the Mediterranean for the summer, the next 10 days seems to be quite promising in that sense. So is there a comment, something that you would like to see, a feature that maybe I was too quick, so you want to see something, please speak up.